Hello, today I wanted to work a couple of percent yield problems to help you out if you're still having trouble with that. So let's go ahead and jump right into it and get started. We'll start with there's a couple different ways that you can work these percent yield problems, and I'll show you two different approaches. First of all, let's look at this question. The following reaction is commonly used to produce lime, calcium oxide, from naturally occurring deposits of calcium carbonate. So if 2.34 kilograms of calcium carbonate is reacted to produce 1.25 kilograms of calcium oxide, what is the percentage yield? Okay, let's start out with our percentage yield formula, which you guys mostly know, I think. And let's see, we'll put it down here at the bottom. Percent yield equals actual over theoretical, if I can spell that right, times 100. Okay, the biggest question that I get is how do I know the difference in actual and theoretical yield? So actual yield is something that you get when you actually run the reaction. Theoretical yield is what you calculate using stoichiometry. In this case, it says calcium carbonate is reacted to produce 1.25 kilograms of calcium oxide. So in this case, we're going to know they're giving you the amount that's produced in the reaction, so that's going to be your actual yield. So we can go ahead and plug that in down here, 1.25 kilograms. Now you might be wondering, is kilograms okay to use as a unit? It doesn't matter what unit you use as long as your actual and theoretical are in the same units. So we can go ahead and plug this in here. Now, all we really need to know is our theoretical, and we can solve for our percent yield. Well, the problem doesn't really give us the theoretical yield, does it? However, it does tell us how much calcium carbonate is reacted, so we can calculate the theoretical. So let's go ahead and fall back on our stoichiometry, and we can go ahead and start calculating what our theoretical yield would be. Okay. All right, so we're given 2.34 kilograms of calcium carbonate. Oops, let's do that better than that. Okay, so 2.34 kilograms. All right. And we want to find the theoretical yield of calcium oxide. Knowing that we're working with those two, let's go ahead and get the molar mass of those two compounds. Calcium, if we look at our periodic table, there, it's 40.08, our carbon is 12.01, and oxygen, of course, is 16. You probably already remember that one. Okay, so calcium was 40.08, carbon 12.01, and oxygen is 16 times 3. So if we add that up in our calculator, we get basically 100.1 grams per mole. Okay, for calcium oxide, it would be 40.08 plus 16, so you're looking at 56.1 grams per mole. Okay, now following our stoichiometry steps, we know we have to convert any masses we have over to moles. Of course, we're given 2.34, let's make that 4 more clear, kilograms, so we can start by saying 2.34 kilograms times 1,000 grams in a kilogram. Gives us 2 grams, and then we can use our molar conversion to get us to moles, and that comes up to 23.4 moles of calcium carbonate. Okay, so now that we have moles, we can use our regular stoichiometric ratios, our coefficients, which in this case are 1 and 1, so this one's pretty easy. So if we have 23.4 moles of calcium carbonate, we also have 23.4 moles of calcium oxide. So I can just basically start with my 23.4 moles of calcium oxide and then convert it back to grams using my molar mass for calcium oxide. Okay, and that comes up to 1,310 grams. So, 1,310. Okay, so this is my theoretical yield. Now this is grams, this is kilograms. You can convert this to kilograms or this to grams. It doesn't matter as long as they're both in the same units. I'm going to go ahead and convert this back to kilograms. And that's going to give me 1.25 kilograms over 1.31 kilograms times 100. And you just plug that in your calculator and you should get 95.4% as your percent yield. Okay, hopefully that made sense to you. Now we're going to look at a different problem where we kind of approach it backwards, where you're given the percent yield and you're having to calculate your actual or your actual yield if you know your percent yield. So let's look at this one. It says, based on the following reaction, what mass of calcium sulfite would be produced from the reaction of 475 grams of calcium carbonate if the reaction has a 96.5% yield? So once again, we know when we do our calculations, that they give us theoretical yield. So if we want, anytime you're given this percent yield, that means they want actual yield, and so you can't just stop with the stoichiometric calculation. I can show you here how that works. Okay. All right, so we're given 475 grams of calcium carbonate, and I want to know the mass of calcium sulfite. Okay, let's do our molar masses again. If you remember, calcium is 40.08 plus carbon plus 3 of the oxygens, and it gives us 100.1 grams per mole. All right, for the calcium sulfite, you've got calcium. This time you've got a sulfur, which is, let's go very quickly, 32.06. And then once again 3 oxygens. So that gives me a total of 120.1 grams per mole. Okay, so now let's start doing our conversions. 475 grams of calcium carbonate times 1 mole over 100.1 grams, so our grams cancel. That gives me 4.75 moles. Okay, once again, this is a 1-to-1. We didn't check this to make sure. You always check to make sure your equation is balanced. In this particular case, the equation is balanced. So we have a 1-to-1 stoichiometric ratio, so we can pretty much just 4.75 moles of calcium carbonate is also going to give you 4.75 moles of calcium sulfite. made these easier stoichiometric calculations, so we don't have to get bogged down in the stoichiometry on these. Okay, 4.75 moles, which means now I can convert this back to a mass. Oops. Okay, that gives me a mass of 570 grams. All right, just remember, this mass that you calculate is actually the theoretical yield, it's not your actual yield, but you're told that you have a 96.5% yield. So how do I find my actual yield? We can start with the same formula. Percent yield equals actual over theoretical times 100. If you solve for actual, then what you're going to come up with is equals theoretical times your percent yield over 100. So in this particular case, we can take our theoretical, which is 570 grams, times our 96.5% yield over 100. And if we put that through the calculator, which I thought I'd already done, but I have not. We get 550, well, 550 if you were doing three significant figures. So that is grams, of course. So that is our final answer. So the main thing is, anytime you're given a percent yield, that means you can't stop with your stoichiometric calculation, because that gives you theoretical yield. That doesn't give you actual yield. You have to continue on to the next step and use your percent yield to find your final answer. All right, I hope that was helpful.